all, welcome to Wolf Magic classes where mastering NCRT concepts are made easy and effective. Let's dive into today's concept. So, yesterday we talked about, can you all remember that? How the effect of change of temperature helps to change the state of matters, right? Now we are going to talk about what happens if there is a change in the pressure. So we have already learned that the difference in various states of matter is due to difference in distance. So this is the important terminology. Why there is a difference? Because there is a distance between the constituent particles. What will happen when we start putting pressure and compress a gas enclosed in a cylinder? While the particles come closer, do you think that increase or decreasing the pressure can change the state of matter? Yes, let us see here. See here, by applying pressure, particles of matter can be brought together, close together, right? So, applying pressure and reducing the temperature can liquefy gases. Yes, that's why our LPG cylinders, oxygen cylinders, nitrogen cylinders are carried in a cylinder in the form of gases, liquefied gases. That means when you increase the pressure and reduce the temperature, the particles will come close together. So gaseous particles will be converted into a liquid, so it is easy for us to carry. So the gas which we are using in our home, whether it is in a gaseous form or a liquid form, LPG, what is the full abbreviation for it? Liquefied petroleum gas. So liquefied, it is nothing but liquefied. So we have converted the gas into a liquid by applying pressure and reducing the temperature. Have you heard of solid carbon dioxide? It is stored under high pressure. Solid gets converted directly into the same manner. How the gases gets converted into liquid by applying pressure, solids gets converted directly into gaseous state on decrease of pressure. Here we need to increase the pressure at and reduce the temperature to liquefy the gases. In order to convert the solid into gas, we have to decrease of the pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is known as dry gas. Have you all seen in many movies and all, they used to bring a smoke, right, without gas, because when this solid carbon dioxide is put inside a water or something, it gives a smoke. So thus we can say that pressure and temperature determine the state of a substance, whether it will be a solid, liquid or gas. So liquid on vaporization is converted into gas, gas on deposition is converted into solid, solid on fusion is converted into liquid. Yes, so liquid on solidification is converted into solid, solid on sublimation to gas, gas on condensation to give liquid. Is it clear? So these are all the cycle how the interconversion takes place. So atmosphere, that is ATM, is a unit of measuring pressure exerted by a gas. So the unit of pressure is Pascal. So 1 atmosphere is equal to, this is important, 1.01 in 10 power 5 Pascal. Pressure of air in atmosphere is called atmospheric pressure. What is in atmospheric pressure? The pressure of air in atmosphere is called atmospheric pressure. So the atmospheric pressure at sea level is 1 atmosphere and it is taken as the normal atmospheric pressure. So always we used to have it as 1. Conversions we'll discuss. Okay, we'll discuss the questions in the next sessions. Now we are going to talk about evaporation. Do we always need to heat or change pressure for changing the state of matter? Can you quote some examples from your everyday life where change of state from liquid to vapor takes place without the liquid reaching the boiling point? Can you able to can you understand this, children? Yeah, if I want to change something, whether I need to apply heat or pressure, only then it happens. I need to go and apply externally. We'll see some real life example. Okay, water when left uncovered slowly changes into vapor. Wet clothes dry up. What happens to water in the above two examples? They are moving away, they are converting into vapor. We are not going and applying any heat to them. That means already sun is there, because of that it's happening, but we are not going and applying directly into it. So we know that particles of matters are always moving and are never at rest. So at a given temperature in any gas, liquid or solid, there are particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particle at the surface, that means on the layer, at the surface. For example, if this is my beaker, I have water bottle here on this surface, this area. So on the surface, what happens here? There are particles with different amounts of kinetic energy. In case of liquid, a small fraction of particles at the surface having higher kinetic energy is able to break away from the force of attraction of the particle and gets converted into vapors. They can break and convert it into vapor. This phenomena of change of liquid into vapor at any temperature below its boiling point is called evaporation. Here arises a new question. Tell me, if here it happens automatically because of sun or something else we are telling here. But when you do it with if you take a bowl, add some water, put it on a flame. Tell me what happens first, boiling or evaporation? What happens first? Yes, evaporation happens first. After that, only we will get a boiling, because evaporation is a surface phenomena. As they said here, the particles at the surface are at high energy compared to all this. So they easily break and they will be converted into vapors. So evaporation happens first before boiling. Boiling is a bulk phenomena. Evaporation is a surface phenomena. Okay. So factors affecting evaporation. So take 5 ml of water in a test tube and keep it near a window or under a fan. Take 5 ml of water in an open china dish and keep it near a window or under a fan. Again take a 5 ml in an open china dish. Keep it inside. Record the observation. Okay, and for rainy day also. So the observation is that if it is under the fan. So mummy used to during your morning routine and all, when you're going to school, she used to prepare the food and she needs to make it at the room temperature. So because if it's too hot, you can't eat. What she will do? She will place it under a fan, right? So fan, and then what other things she will do when she give you a cup of coffee? She used to place it in a saucer, right? In order to increase the surface. So all these things I'll explain you here. So if you increase the surface area, from a glass to a saucer, glass the surface area is less, saucer the surface area is high. So if you increase the surface phenomena, evaporation also increases. That's why while putting cloths for drying, no, we used to spread it, right? We doesn't put as it is. We will take it from the washing machine and we'll dry as it is. No, we need to spread. So increase the surface area, increases the evaporation rate, as well as an increase of temperature. With increase of temperature, more number of particle gets enough kinetic energy to go into the vapor state. So increase of temperature also increases the evaporation. Decrease in humidity. What is in the humidity? Humidity is the amount of water vapor, not water vapor present in air. So if it decreases, listen carefully, if air contains already some moisture content, there is no sun at all, will it be possible to dry our clothes easily during rainy season? Because already the air is surrounded with water vapors. It is staying there. It doesn't allow any heat to come inside, or it doesn't already it is filled, air is filled with water vapor. There is no chance for the light and heat energy to come inside. So what happens? If the humidity is less, there will be water vapor will be less around the air, so we can get directly the heat from the sun. So the air around us cannot hold more than a different amount of water vapor at a given temperature. So if the amount of water in air is high, the rate of evaporation decreases. So the rate of evaporation increases because of decrease in humidity. You can understand this by when you dry clothes in rainy season, when you dry clothes in summer season, which gets faster. See, if you put it at 1 o'clock, you can take away the clothes by 4 o'clock. But during rainy season, it is not possible, right? Because the humidity is high. So increase in humidity decreases the evaporation rate. Decrease in humidity increases the evaporation rate. So the increase in wind speed, yes, in order to dry anything faster or in order to make the food easy to eat, we need to bring it to a room temperature. Mummy used to spread it on the plate and she used to keep it under the fan. So it is a common observation that clothes dry, even though clothes, right, on windy days. With the increase in wind speed, the particles of water vapor, what happens? When you increase the wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surroundings. So when you put on the fan, the water vapor in the air goes up. Again, the water vapor around the food also goes up. So from here, always listen children, hot air moves up, right? So it increases, the wind speed increases. So factors affecting evaporation, we have learned 4 points. Increase in surface area increases evaporation, increase in temperature increases the rate of evaporation, increase in humidity decreases the rate of evaporation, decrease in humidity increases the rate of evaporation, increase in wind speed increases the rate of evaporation. Okay, so how does evaporation causes cooling? You all observed when you when you put a nail polish or a nail polish remover on your palm, you can feel the chillness. What happens here? The particles will gain energy from your palm, or we can simply say heat from your palm, and it evaporates. So there is a lack in the heat energy on your palm. So at that instant, you will feel chill. After a hot sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface, because the heat is hidden on the surface, right, hidden on the particles. So when you sprinkle water, it will takes up the heat, and the water will evaporate and leads that area to be cool. So evaporation causes cooling because it uh, suck all the heat around the surroundings. So why should we wear cotton clothes? During summer we perspire. Perspire means we used to sweat a lot more because of mechanism of our body which keeps us cool. So we know that during evaporation the particles of the surface of the liquid gain energy from the surrounding or body surface and change into vapor. So the heat energy equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. So the water will take the heat from our body and it evaporate. That's why it leads to cooling. So we need a source for it, right? If we wear a jerkin or any nylon related clothes, the water will not be absorbed, it will stay in our body itself. But cotton clothes will absorb the water and it is evaporated, it causes cooling. Why do we wear? Why do we see water droplets on the outer surface of the glass containing ice cubes, ice cold water? So it is a that you know glass. If you place some ice cubes and keep it on outdoor, you can see the water droplets on its surface, right? So let us take some ice cold water in a tumbler. Soon we will see water droplets on the outer surface. So the water vapor present in the, what happens here, the water vapor present around the tumbler, right, on coming in contact with the cold glass water, loses its energy and gets converted into gas. What happens here? Here the gas is converted into liquid by decreasing the temperature, because the ice helps to decrease the temperature. So that's why we see the water droplets around the surface of the tumbler. Okay, I hope it's clear, children. In tomorrow's class, we will be discussing the question answers. First, we'll complete all our in-text questions and then we'll go to our book back questions. Okay, thanks for joining us at Wolf Magic classes. Don't forget to like, share, and subscribe to reach more students. Keep practicing, keep learning. See you all in the next video. Bye.